At this point in the construction process, the concrete for the new Connecticut Science Center's parking garage has been poured. 14,355 cubic yards of concrete have been used to create the garage upon which the Science Center will rest. With the first piece of steel hoisted into place and bolted up, the workers launch into the next phase of the building process. The structural steel used to build the new Science Center is fabricated by Saveys Steel, located here in Augusta, Maine. More than 3,000 tons of steel will be used to create the frame of the Connecticut Science Center. Today, our job is to understand the process of creating steel. And we have with us Chris Coulthaw, who's going to explain the process to us. How are you?
I'm fine, Chris.
Great to have you here.
Thanks.
Can you get us from the factory to the job site in terms of how steel is made?
I'd love to.
Thank you.
At Saveys, we fabricate the structural steel that we receive from the mills. Nucor Yamada uses an electric arc furnace to fire, refine, and process the recycled material that makes up our steel. Steel is iron with impurities such as silica, sulfur, and phosphorus removed. Because the impurities are removed, the steel is much stronger than iron. The iron is heated to 2,400 degrees to become molten steel. Alloys such as carbon and manganese are added to strengthen the steel, depending upon how the steel will be used. For the Science Center, the formula for the steel is 95% recycled iron, carbon, chromium, manganese, nickel, and silicon. The molten steel is then drained into continuous casters that create the beams, columns, and other parts to be used in the building. Even before we get to this point, the architect who designed the building provided the detailer with drawings that outlined the structure of the building. The job of the detailer is crucial if the building is to come together correctly at the job site and withstand the wear and tear of the elements for years to come. The detailer is responsible for making a 3D image and drawings of the architect's plans for every piece of steel with its holes, bolts, and clip angles. Every time a change is made to the plans of the building, the detailer must make a new drawing and then determine how the change affects the rest of the building.
Between the project manager of the job and the detailer, project manager will get the RFI telling them to change it, or whatever the information to change it. They give it to the detailer, and it's the detailer's job to actually track what changes, how much it changes. Right, like you said, if they move this beam, it would affect this beam, the beam down here, another beam, and depending on what else is framing into those areas. So it's pretty easy if you're dealing with a system like this. If you move that beam, instantly you can tell that all of a sudden the beams it was attaching to were no longer in the same spot. So it's usually pretty easy to follow it. With a system like this, if you're doing it in AutoCAD and you're just drawing a piece here and there, sometimes it can get a little bit harder to follow all the pieces it affects. But in this case, I moved this brace and I can see very quickly all the pieces that it will affect.
The shop drawings made by the detailer must be signed off by the architect. The computer-generated shop drawings inform the fabricators where to put the holes and angles and bolts in each piece of steel. Once the shop drawings are approved, the steel goes into the fabrication process where each piece is labeled, cut, drilled, welded, and if necessary, cleaned and painted. Depending upon its use, a steel beam can go through several different steps. The fabricator even controls the management, transportation, and erection of the steel. Because the Science Center job site is small, each delivery of steel is timed, and each delivery of steel has the precise pieces required for that day's work. No more, no less. Everything needs to be carefully planned. Even highway regulations need to be taken into consideration. Once at the site, the steel is hoisted into place and the workers bolt it up, and then tie the steel down in place. Each piece is assembled according to the erection drawings provided by the detailer. It should take approximately 3 months to fully assemble the steel skeleton of the Connecticut Science Center.
Chris, thank you so much for helping us understand the jobs, the science, and the planning that goes into creating structural steel.
It's been my pleasure.
Now that the frame of the building is coming together, next steps include fireproofing the steel, installing the curtain wall, and installing the utilities. Here are excellent websites to continue your research on the creation of steel. Thank you to the following organizations and individuals for their help.